was that?
That business major guy.
Oh, Joe.
It's just kind of like.
Yeah, he's probably another reason why the investor thing is only half done. He's supposed to be running that team. So you got him. Oh, yeah. So you got him and then 2 developers. He's not developing. He's the business guy. Yeah, so that's...
So it's kind of like, it's hard to teach when you got someone who's seriously not listening and someone who's, like, watching your lips as you talk, you know?
Yeah, I know. Join the club.
I don't think I could stand that. That's how I'm not an education major.
Yeah, I would say the average class, you probably have maybe 10% of the class very engaged. Maybe 20% of the class that seems to be paying attention. And then the rest of the class is just literally just waiting for the class to be over. Like, I just assume he's playing a game or something. What's going on the laptop?
Reddit.
Actually, one of the things I like about him is he's direct. He's not going to BS me. He just, hey, look, this is what's going on. Earlier in the semester, he disappeared for like 3 weeks, I think. And he came back, he's like, oh, you're finally here. It's like, what's he? There's not a lot to say. I was gone. It's nice to be missed. But he is a possible source for Skyline Chili from Cincinnati, so I need to stay in his good graces. All right, so for those of you who had to do the homework, how did it go?
Well, I don't know if I actually did it right.
Okay. So an interesting pass on that. So while the people at the hackathon were having to take a problem that they weren't necessarily spoon-fed, let's say, and try to come up with a solution themselves, the rest of you had to do effectively the same thing, right? You had to go read some documentation, say, okay, well, what the heck is this, and how can I possibly solve this? So let's go ahead and bloom filter. Yeah, whatever. That's fine. We'll do empty activity.
At the hackathon next year, you need to get all Concordia students together for voting, because we easily could have taken first, second, and third if we only voted.
Hey, I came over and told you guys to make sure you voted, and you guys were just sitting there like idiots.
We all voted only for our team.
Oh, really?
Well, you got 3 teams,
Well,
so you should vote for.
but one group didn't present.
Doesn't mean you can't vote for.
They weren't. No, you couldn't.
Yeah, you can only vote for the teams that presented. So you should vote for those guys, and then just not vote for anybody else.
You don't want to
Did the winner win anything?
Yeah, but you got to go and pick a prize. I think the top prize was some sort of like robotics thing. I think it was like a couple $100 thing, right? The top prize was like,
That's what it was.
huh?
It was
Rock'em Sock'em Robot.
No, there was another thing up there. No. There was another thing. It was a robotics kit.
Are you sure?
At least it was on the website. I never actually looked at the prizes.
There was nothing other than like games and a mouse up there.
Okay, so that's fine. So yeah, so let's call it party prizes. Well, the mouse was pretty decent, wasn't it?
Yeah, but the groups that won all had apps coming in.
Yeah.
All they did was fix bugs. Which is
And I get that, and that's something you do run into. I would say what was nice about this hackathon is that it was relatively short, so only 8 hours, so like relatively easy time commitment, and it was local. When you go to some of the bigger hackathons, that wouldn't have been allowed. So most hackathons, the rule is everything that you present was created there. You can't come in with any pre-created stuff.
But like that Fox one that won, like they like literally said they added like nothing other than
Right.
fixing bugs.
Well, they added the thing where the fox could talk to the tree,
Oh.
and also the rock.
That was the elephant one.
No, I'm talking about.
Yeah, the
fox
elephant,
that,
was
like,
already there.
flew up and
Fox
down.
one.
Oh, the fox was a flying one. You're right. That was the elephant one.
It was supposed to.
Yeah.
Maybe elephant one. Looking for its nothing.
Yeah, didn't they get like second?
Yeah.
Yeah.
It was all
See, I didn't even think that was all that impressive. Anyways, even if they had been done from scratch.
The guy that won, that was really cool.
Yeah, but I think that app had already been worked on for a while. But I agree.
Much of that.
Yeah, I agree. But at least this hackathon was kind of advertised with that in mind, where come and work on stuff, show what you have. And I was impressed that the groups that did already have some stuff done at least got up and said, this was what was my starting point for today. They didn't try to act like, I showed up today with an empty hard drive. I installed the OS, and then I did this. So.
In the front row was creeping me out.
Guy in the front row.
He had like long hair, and he asked about 1,000 questions, and he like seemed like he was gonna have like a panic attack. He was having so much fun there.
Oh no, I know who you're talking about. Yeah.
That guy couldn't figure out how to plug in his computer. He like ran up there. I was like,
Yeah,
this guy is-
I was getting a little bit of a creep vibe off him
I'm
too.
not letting my children own that guy. Tell you that.
Figure out how to plug in his computer.
Well, they had like a bunch of weird plugins up there. But there was another guy. I think he ended up presenting, but he. Did you ride with me? Did you ride? Okay, we passed this car on the way there, kind of like after we got off the interstate, and we were in the middle of talking about something else, and we looked over and says, "Oh, this guy doesn't look like he's up to any good." Just almost gave off like a Unabomber type vibe, right? Yeah, you rode with me, right? Yeah, totally was at the hackathon. Spotted like, hey, wait, that's the car. That's the guy. Yeah, there was some stuff, but I thought it was a good like beginning hackathon.
We wasted 3 hours trying to get Android Studio to work on mine and Josh's, and then just gave up because we didn't realize that there was an update that came out a couple days before.
Well, I think there's also even some value in that. So consider just time management, right? So like your group basically restarted at least twice, right? So sometimes and also you have these dreams of what the project can be, instead of getting, like, for instance, Tim Huseman, who's a senior, he was working on a project. And I was horribly disappointed at him. Just a joke. I hope he listens to this. So, like he spent, it seemed like 2 hours on like authentication and registration and stuff like that. Well, in something like this, you hard code a username and password. Put it on the website, log in. You don't build a registration page and spend a quarter of your time doing that when you want to have features you can show, right? So that's all just time management and also experience.
Yeah.
You have to make those mistakes for a couple of hackathons before you realize that, oh, if I spend time on things that people don't care about, nobody cares about registration. It's a necessary evil if you're ever going to release the product, but nobody cares about registration. You need to kind of make that screw up for a couple of hackathons before you get around to the point where, like, oh, well, let's focus on features that people care about first. So for many groups there where this was kind of their first hackathon, that's a reasonable mistake. Okay, I want to say that this was like Tim's like maybe 15th hackathon. I've been all over the country with that guy, so it was. Although this was the first time I put him in charge of a team, maybe that was a mistake.
See, I thought it was funny. Josh, our leader, he's like at the start. He's like, okay, we can easily finish all these projects and have time to spare, and then we barely got the main part done.
But I think that he did a pretty good job.
Yeah, he did a good
Yeah,
job.
from as a student leader in a hackathon, I thought that he kind of went the route that you guys needed to go. Although you still restarted your project too, right?
We just couldn't get Android Studio to work on either of ours, which didn't help. We didn't really restart it ever. We gave up on it and came back.
We gave up on it. Okay, so you gave up on it and came back to it. What were you doing while you gave up?
He was gonna build that server where you can talk about stuff anonymously. Because
Okay.
he already knew there was code on Firebase where it was almost the whole thing.
Yeah, Firebase makes chat stuff relatively easy.
I didn't understand the whole maze concept until the very end when we were actually playing the game. The way he described it, I thought it was just like there was walls, but we're actually going along the lines. He didn't tell me that. So I was confused 90% of the time.
Well, yeah, but it didn't matter. You were the graphics guy.
Yeah.
Just shut up, sit in the corner, and make pictures.
I took the weight out of some nice arrows.
Yeah, alpha out some backgrounds. Nice.
I had one other thing that someone helped. Well, we didn't end up using it.
So you wasted your time. That makes sense. I get it.
But we got free Chipotle, so that was the important part.
Point. Yep. All right. So, having said this, let's go ahead and yeah, this was all a ploy to not have homework tonight, right? All right. So let's go ahead and build a simple little interface for this app. Ultimately, we're going to want to add stuff to our list and kind of build out our Bloom filter. I don't care for this homework assignment whether you displayed it on the screen or put it in the background. But what we're going to start off with today is approaching these hash functions. So my guess is, for those of you who had to do this homework, one of the sticking points for you was wrapping your mind around what the heck is a hash function and how do I make up simple hash functions, right? Is that a fair statement? All right, so we're going to build 3 different hash functions. We're actually going to build one hash function that is modular. You can turn it into 30 different hash functions. It's a ghetto hash function, so it's not going to be something you'd want to really use in true production, but it's going to accomplish what we need it to accomplish here. So for right now, we're going to build just a text box with a button that submits and then prints out to a label the hash of that value. All right, that's our starting point. Let's see here. Oh, actually, we can. Does it seem like this screen is smaller than it usually is? Oh, maybe it's this guy. Oh, wait, I can do this, right? Boom. Awesome. Okay. Exactly what I was trying to accomplish. Okay, so let's go ahead and give ourselves a. I hate the fact. All right, we're doing something here. Isn't that just stupid? Let's do activity underscore main. Delete anyways. New layout resource file. Activity underscore main. It's going to be a linear layout. All right. All right, we have extracted and re-implemented. Now life should be easier. So let's go ahead and we're going to drop in a edit text. And then we're going to drop in a button. And then we're going to drop in a text view. Well, actually, we can just do this with fill parent. There we go. And then we can set the gravity on that guy to center horizontally. Okay, and let's make the text a little bit bigger. So let's make the I guess it wants it like that. So then with that in mind, let's go ahead and also set center vertically. Okay, we'll say that's good enough. All right, and this is going to be our output. Just call it text view. Hello. And the button is going to say, let's just call it, well, we'll ultimately call it add. So let's just leave it like that. And then we need to give this guy a name. This guy is going to be input ET for edit text. All right, so let's go ahead and give ourselves programmatic access to that. And actually, let's go ahead and throw in our on-click on this dude. Add button pressed. Perfect. All right, so let's go to our main activity. And before we forget, let's do public void add button pressed view v. All right, so that's what's going to happen then. Activity main is now a thing again. That's a much more efficient way of accomplishing what we've done in the past, right? Deleting the relative layout and adding the linear layout. I wonder why they don't. When you create a new activity and choose to have a layout associated with it, I think you could choose what you want the base for it to be. But I wonder why it does relative by default for everything else.
What was that shortcut they used to import?
Option enter. I think it tells you what it is, but it just on a Mac it gives you like the weird funky symbols. It's like reading Klingon. It actually is similar to reading Klingon. We've looked up recently. Well, I was in here, the Klingon alphabet. 200. We were deciding for number conversion bases whether we would actually be able to handle bases greater than base 37 if we used Klingon. The answer is no. But because there is an official Klingon language, by the way. I think there's only 23 characters in it. I read it, I don't speak it. That would be pretty funny. At some point, we should do a Klingon translator. That would have been a funny hackathon application. And I bet you that application would have finished top 3.
Oh yeah, even if you didn't finish anything, you just said
This is a Klingon translator, and we used the actually, you could do this. How would you do it? Yeah, you can use IBM Watson API, which does text to voice. So you could actually have it be a translator for Klingon. And you could feed it sound waves, I think. That would be really funny, even if it wasn't even accurate. You just randomly generated Klingon, like, just something. By the way, that was hello in Klingon, in case you... I speak it a little. I read it fluently. All right, so let's go ahead and give ourselves our buttons and stuff. So we're going to call this guy private. What is it? Edit text. Input. ET. And this would be private text view. Output TV, or whatever I called it. Is that what I called it? Mm-hmm. All right. And then we'll go ahead and say this dot input ET is equal to the edit text version of this dot find view by ID r dot ID dot input ET. And this dot output TV is equal to text view version of this dot find view by ID r dot ID dot output TV, like that. Oh, and before I forget, are you able to meet tonight? Or is that
Yes.
okay? I had to cancel my wife had her surgery stuff yesterday, and she was loopy for longer than she was advertised as being. Everything went fine. She just couldn't really. I figured I'd come home and find her on the floor. Somewhere halfway to the bathroom, she went down or something. But yeah, she's fine today. All right. So we now have programmatic access to those guys. Let's just prove that everything's kind of hooked up. So when we click this button, we'll go ahead and say this dot output TV dot set text to this dot input ET dot get text. And let's see how this thing zigs and zags. It was pretty funny yesterday and infuriating at the same time. She asked the same questions like 30 times, my wife, as she was coming out of the science. And one of the questions, she wanted to know how many times she had peed. Like, of all things to worry about, just keeping count. But so then I start screwing with her and telling her like just unreasonable numbers. Like, well, we've been home for 2 hours and this is number 18. So, I'm sure it's just the chemicals leaving your body.
There's a viral video on YouTube of these two brothers convincing their sister who was getting out of, just finishing up on being a wisdom teeth removed, so she was really be convinced her of that the zombie apocalypse was currently.
That would be pretty awesome. See, I don't think my wife would find that funny afterwards. I would find it hilarious, especially if I recorded it, which she would also not find funny. But I mean, we've been married a while, so I figured like I could survive the ride. So she'd be mad at me for like, I don't know, 2 weeks. And finally just cough it up to, well, should I have really expected anything different? All right, so all this crap seems to be connected up, so let's go ahead and give ourselves a, why don't we put our hash algorithms in like a little singleton, just to kind of call them when we need it. That way we can make this relatively easy, I guess. So I'll go ahead and do new Java class, and we're going to call this guy core. Okay, and we'll go ahead and put in this public static, let's call it gen hash. This guy will take in a string s as a parameter, and we're going to take a let's take it an int rot count for rotation. So this is kind of based on the rot 13 algorithm for it was called the Caesar cipher. So you have 26 characters in the alphabet. So if you took the letter A and you encrypt it, it just goes 13 characters forward, right? Okay, so we're going to rotate every character they send us some number of characters. Now, that's not good enough for a hash, because a hash has to have an arbitrary size input and a fixed size output, right? But we're going to start off with this rotation. So if we say rot count is 4, that means every character will become 4 things further in, right? Okay, and then we're going to figure out how do we shrink this down to something smaller, and hopefully you'll see how this is going to end up working. All right, so we're going to rotate first. So we're going to go through every single character in S. So we'll say, we're going to build a new string. So we'll say string answer is equal to the empty string. We'll say for int I is equal to 0, I is less than s dot length I plus plus. And each time through, we want to rotate inside of the alphabet the current character. Okay, so for example, A, if we rotated 3, would be B, C, D. We'd add 3 to it, so that would become a D. But now Z would go to A, B, C, would wrap around in the alphabet. Okay. In our example here, let's just go ahead and assume that actually we could do this. I was going to say we can just assume that the input they give us is a English character, but for in our world that doesn't necessarily matter. The maximum size value in the Unicode character set is 65,536. It's 0 to 65,535. So what we can do is we can take the current Unicode value of the character we're looking at. We can add rot count to it, and then mod it by 65,536. And that should give us a number between 0 and 65,535, handling the rotation. So we'll say answer concatenated with s dot charat I. That's going to give us a character. Turn that guy into an integer. So that's an int. And then we're going to add to that rot count. And then we'll mod that by 65,536 for the number of unique characters in the Unicode character set. Okay, we know that the char we're extracting from S is some character that's a legal character in Unicode. All right, and we'll go ahead and add to it whatever our rot count is, and we'll mod it by 65,536. Fine, for no good reason other than we're just jumbling up a string. Okay, and this is, even for our hash, this isn't even necessary to make a super simple hash, but we'll say that this guy gives us something. So for right now, let's just go ahead and return answer just to see what this gives us. And this guy's going to return a string. Okay, so we'll run this through our gen hash and we'll rotate by, I don't know, 7 or something like that. We should see a jumbled up version of whatever we passed it.
When you're, can you go back to core? What is it adding to your string? Aren't those integers?
Oh, it is. That'll be the char version of that. I think, actually, at the end of the day, it wouldn't have mattered, but you're right. This won't take it back to it wouldn't have taken it back to a character. It would have just tacked on a number. All right, so we'll go ahead and add to this core.genHash. This is our string we're hashing, and we'll go by 7. Something like that. We can hide this right now. All right, so we'll hash that string, whatever we type in, and that'll give us a 7-character version of it. I'm sorry, a rotated 7 version of it, but it should still be the characters that we had, the same number of characters that we had before. So we'll say hello, and there's our hashed value of it. Let's do zebra. Yep. Oh, awesome. So remember before I had told you that the Eclipse terminal doesn't support all the Unicode characters? It appears like this guy does. So if we say 1300, since we know there's lots of characters in the, we should hopefully get some nice foreign characters out of this. Oh, there we go, a bunch of squiggles and stuff. Legit stuff. Okay, so we're converting, or we're encrypting our data at this point. I don't think Unicode supports Klingon, but it should. So whatever we're going to rotate by, it doesn't really matter. This supports any Unicode character, and we're modding by 65,535. So even if we do the final Unicode characters, it'll still wrap back around. All right, but now what we need to do is we need to ensure that the value that we return is going to be, an output of a certain size. Okay, so we need to decide what our output size is going to be for our hashes. Well, for the homework assignment, didn't I say that M would be 18? All right, so our hash needs to produce some value between 0 and 17. That's the deal, right? So what we're going to do, so here, I'll ask you first. If I have a string that has s dot length number of characters in it, how would I get a number between 0 and 17 out of that string? Any takers? Or is this the deer in the headlights, nobody's participating thing?
What do you mean by that?
I have the string hello, and I want to turn it into a number between 0 and 17. Suggestions?
Sum up the characters and modify 18.
Yeah, sounds pretty legit to me. So we're going to just spin through the whole thing, add each Unicode character up, giving us a number, some number, right? And then we mod it by 18. When we mod a number by 18, we're guaranteed a result between 0 and 17, right? Mod is the integer division. So we wouldn't have a remainder of 18 because that means 18 would have gone into it another time. So we can actually go ahead and get our sum while we're doing this. So we'll start sum off at 0. So with that in mind, let's go ahead and give ourselves a temp. And this is where I can say, oh, I did this on purpose. All right, so we'll end up, let's see, am I missing a, there we go. So we'll go ahead and say sum plus equals temp. And then we'll say answer is equal to the char version of temp. And this guy in our world right now is actually going to return an int. And we'll return sum mod 18. Right, that's going to be our hash value. So some number between 0 and 17 should be what that gives us. So this is the sum of all the encrypted, all the shifted Unicode characters in S, summed up, modded by 18, should give us some number between 0 and 17. Short version of this is we probably didn't need to rotate, but it was sure cool to do it. So, especially since we can I don't know, get weird stuff out of it. All right, so let's go back here, and we will go ahead and this gives us our hash, and we need to go ahead and concatenate that onto the empty string because it came out as a 0 to 17 number instead of a string. So now, no matter what string we put in, we should get some value between 0 and 17. So we say hello, there's our 12, hello world, there's our 8, bang on the keys some, 17, bang on the keys some more, 16, so on and so forth. So we can say we've exhaustively tested this and we have guaranteed it's going to give us a number between 0 to 17. And we know that because of the rules of math. And if we take anything and mod it by 18, we get a 0 to 17. All right, regardless of the stuff we did before that. All right, makes some sense? All right, so now let's go ahead and store in our core also our current Bloom filter. All right, so we're going to say public static, and this guy is going to be a bit array of what I say for the homework, 18 bits. All right, So for us, that's going to be an integer array. We just are going to happen to choose integers 0 and 1. Those are going to be the actual dudes we put in there. So an int array called filter, and this will be a new int array of size 18. So that's our M. Okay. So we'll leave it like that. What we can actually do is we could do something like this: public static int M. We'll do a capital M is equal to 18. Public static int K is equal to 3. I think was what I had said in the homework. So this will actually be M, and then we'll use the K someplace else so that it's we can make this relatively generic if we want to create bigger filters. Okay. So here's our gen hash. Now we're going to go ahead and create a function in here. Public static void add to filter. All right, so when we add a, and this guy's going to take in a string s as a parameter. All right, so now when we add this guy to our filter, what we need to do is we need to generate 3 hashes, right? Well, k number of hashes of our value. And for each of those hashes, we're going to get a number between 0 and 17. And what do we do with that number between 0 and 17? We set the bucket in filter at position 0 to 17 to a 1. Correct? If it was already a 1, what do we do? Overwrite the 1 with a 1? Just stays a 1? Okay. So we say add to filter. First thing we need to do is we need to generate some number of hashes. So we're going to create a int array called hash values. And this guy's going to be a new int array of size k. That's the number of hash values we're going to have. Okay. And then we're going to go ahead and say for int I is equal to 0, I is less than k, I plus plus. So we'll go through k number of times. Each time we need to go ahead and grab a hash value. Okay? And we need to be consistent for our hash values. We can't apply different hash values to the different inputs. So maybe we decide we're going to have our hash value be, I don't know, we can maybe just shift 0, 1, 2, or maybe we actually start with 100. We just assume that we're not going to have a k of 65,535. So maybe we start off with the shift of 100. So what we'll do is we'll have int initial shift is equal to 100 for no good reason, and then we'll go ahead and say filter at bucket. Well, let's get our pause first. We'll put it in an extra variable. So we'll say temp pause is equal to -1. Actually, we don't even need to start it off with something. Temp pause is equal to gen hash, passing it s, passing it initial shift. And that guy's going to give us some number between 0 and 17. So then we'll go ahead and we'll say filter at bucket temp pause is equal to a 1. Set that position to a 1. All right. And then we need to go ahead and say initial shift, I don't know what, plus equals 13 for no reason whatsoever, just that looks mathy. All right, so we'll shift again, but we'll shift plus 13 for each of our k hashes. So we'll go through again and we'll hash again. But the important thing is that every single time we add something to our filter, the first hash is 100, the second hash will be 113, the third hash will be 126. So we're consistently applying our filter to every single value that we try to add to our set. All right, so this guy will take a string, it will add it to our list. Now, what we also need to do is we also need to have public static. Let's make this guy a linked list of strings, and we'll call this guy values, and this will be a new linked list of string. So after we've actually created the hash, or even before we create the hash, whatever, we need to also actually add the value to our data, the data we're keeping track of. So we'll go ahead and say values dot add. Here we'll add it to, is this add last or whatever? Yeah, we'll just add it to the end. And we'll add s. All right, so that guy will now be added to our list of actual values, as well as we'll mark our filter appropriately for the ones. So we should update a maximum of 3 positions on our filter, but we might do less than 3. We might have collisions here, right? We might have the same number between 0 and 17 returned for multiple versions of our hashes. Okay, so we have that guy. And at any point in time, our filter should be a bunch of zeros and ones is the idea. So when we first create our filter, actually what we can do, let's do this. Public static void initialize filter. So we'll say for int I is equal to 0, I is less than filter dot length, I plus plus, and we'll say filter at bucket I is equal to 0. So we'll go ahead and initialize our filter with a bunch of zeros. I think I can also, that's not going to let me fill it there. So we'll just do it this way. Just show you this guy. So I can say fill filter with zeros. That'll do the same thing. Just a helper function. Have I shown you that before? All right, so arrays is a, well, so here, tell me based on documentation. Fill is what kind of animal? Is it a field, constructor, or method? Which of those is fill? Based on what you're seeing right here. If you were to try to identify fill in the wild, what would you say this guy is? Not rocket science.
What is the question again?
I asked it twice. It's a method. This guy's a method. So the kind of animal this guy is a method. Okay, is it a class method or instance method? And how do you know? Or why would you strongly suspect that? Class method, how do you know?
Arrays is capitalized for one.
Yeah, so you suspect this guy is the name of a class because it's capitalized. So since this guy's being called with the name of a class, this guy's likely a class method. We know it's a method because of the parentheses, and we also know that it's not a constructor because it's not following the new keyword. All right, so this will fill it up with a bunch of zeros. Let's then also have a public static string get filter string. And let's just have this guy say string answer is equal to the empty string. And then we'll say for int I is equal to 0, I is less than filter.length, I plus plus, answer concatenated with filter at bucket I concatenated with \t for tab. All right, and then ultimately we'll return answer. So Now, after we add something to our values, we should be able to see an updated version of our filter. All right, so let's go back to main activity. So up here, we'll go ahead and say core.add to filter our string. And then we'll go ahead and set our text equal to core.get filter string. And that'll show us the current version of our filter. All right, so we'll go ahead and add hello. So there's our current filter. We'll add world. Updated a couple other things. We'll add elephant. We'll add chill. It's my new word. I've learned. Oh, this was this the class that was the bad influence? Oh, that's 450. My 200 class taught me the word chill. Then my 450 class taught me the phrase Netflix and chill, which has gotten me in trouble a couple times. That was further, what was I think it was the show The Flash that was used in The Flash, the TV show. I was catching up on it over the weekend and they used that phrase, so I got the joke. See? So there was some benefit. All right, so this was kind of the homework assignment. Show the bloom filter. All right, so that's half of bloom filter. So now, based on what you read, what's the purpose of a bloom filter? Okay, without having to search the list, we're just trying to determine whether something actually exists in our list. Now, for us, we could probably put together a pretty simple search on our values to determine whether something is there, including, I think we can just say values index of, and you can give it, I think for strings it would use compare to tell us whether something was there. But what we're doing is we're trying to look for maybe false positives. So that's something that could potentially happen. So let's go ahead and give ourselves a function that allows us to determine whether a string is actually in our list. All right, so that's the real deal. All right, so we'll say public static boolean is actually in values. String s, and we'll go ahead and say for int I. Actually, we can use an iterator here. So we'll say for string s in. Just a string val in values. This is a for each loop that'll iterate over every element of this guy. So this is equivalent of saying for int I is equal to 0, I is less than values.size, I++, and then having to say string val equals vals get I. This does all that in one fell swoop. So this will be each value of our linked list as we spin through it. And we can say if val dot equals s, return true. We found it. If we survive the minefield, we'll return false. We didn't find it. Make sense? All right. So that's determined if it's actually in the list. So now, let's go back to our documentation here. So bloom filters. All right, so we've generated this guy with a k of 3, and we can pretty easily create a bigger than k of 3, right? Doo, doo, doo. All right. Oh, let me actually go. The example, I think, shows what we need. Query for an element, test whether the element is in the set, feed it to each of the k hash functions to get k array positions. If any of the bits of these positions is 0, the element is definitely not in the set. If it, then all the bits would have to, if it were in the set, they would all be 1 when it was inserted. If all are 1, then either the element is in the set or the bits have been changed by one of the other guys, right? So we're going to run it through our 3 hashes. We're going to get the position of where the 1 should be, right? They might not be all unique positions. And if all of those guys are equal to 1, then we're going to determine that this value is likely in our set. It isn't definitely in our set because it could be that another value set some of those 1s. That makes sense? All right. So now we'll have public static Boolean is likely in values. This guy will take in a string s. And we'll go ahead and when we add to filter, we're going to do this initial stuff right here. So we'll do our exact same hash value stuff. We could probably put that in another function, but whatever. So these are where the 1s should be. And we're going to go ahead and return let's see. We don't really need to store it. We just need to do some ands. So I don't need that. We'll go ahead and get our this is a value. We don't need to store it anywhere. So we'll say if filter at this position is not equal to 1, return false. If we're still kicking, we'll always increase our initial shift. We need to increase it the same way we did before. If we're still kicking out here, we'll return true. That means for each of those hash functions, we found a 1 inside a filter. Whether it was a 1 that we had previously set ourselves or not, it's a 1. All right, so that's is likely in values. All right, so now let's go back to our interface here. And let's give ourselves a couple of additional buttons. So I'm going to go ahead and we're going to throw, how do I get back to my, there we go. So we're going to throw a horizontal linear layout by our buttons. Put that button in there. And then we'll go ahead and throw another button in there. So we have add, then we have search. Doesn't matter what we call the button. All right, fair enough. And then for this linear layout, we'll make this guy's gravity be center. row. They're both inside the linear layout, right? Oh, it's because that guy was huge. That's why. All right, so there's our add and our search. Let's go ahead and give our on click for this guy. This is search button pressed, like that. And when we click the search button, so this is always going to be our filter. So let's go ahead and say current filter here. And then below that, let's go ahead and show for search whether it was actually there and whether it is probably there, the two different values we have. So we'll throw another horizontal linear layout after our output box here. Okay, and that's weird. Okay, and we're going to go ahead and throw a couple of text views in there. Okay, and we'll make this guy also centered. Where's gravity? Is it a spelling thing?
It's already open.
Oh, thank you. All right, and we'll center horizontally, and we'll say actual. This guy will be called actual TV. And then this guy will see, we'll say likely. And this will be likely TV. All right, and then we need a couple of spacers in there. We have a nice little spacer thing somewhere.
You can add what's called padding.
Oh, we could pad this guy.
Yeah.
So we can do maybe 5 at the end. And then we can do maybe 20 at the end. We'll say 5 again, something like that. Whoa. We'll say that's good enough. All right, we have access to both of those guys. So let's just say we'll show those guys as true and true for right now. Okay, and we can shorten this up. And then let's go ahead and set the gravity inside of, did I lose it again? Oh, there we go. Let's center it both. There we go. All right, so we'll go ahead and set those values based on actual things when we click our search button. So what do we call this? Search button pressed. Search button pressed. Like that. All right, and what we're going to do is we need to go ahead and we'll make these private variables as well. So we have a private text view actual TV and private text view likely TV, and we'll give ourselves access to those. Actual TV is equal to the text view version. This dot find view by ID, r dot ID dot actual TV. This dot likely TV is equal to the text view version of this dot find view by ID, r dot ID dot likely TV. And then for right now, let's say this dot actual TV dot set text is maybe equal to n/a. This dot likely TV dot set text is equal to n/a. Something like that. And then when we do our search button, what we'll do is we'll say this dot actual TV dot set text equal to the empty string concatenated with core dot is actually in values this dot input et dot get text dot toString. I'll just type it again. This dot likely TV dot set text is equal to the empty string is likely in values this dot input et dot get text dot toString. All right, and we'll see if we can get some false positives or something like that. Okay. So let's add a few things. So we'll say hello world elephant. Let's say that's good. So when I do a search for elephant, it should be true, true. If I do a search for hello, it should be true, true. But now if I do a search for LOL, all right, we got actual and likely both false. Let's do woot. Actual and likely both false. Okay, also false. I'm searching for false positives. We might not have time to find one, but it is possible to have a false positive here. Let's bang on the keyboard. I might have just as good of a chance of getting a false positive as anything else. All right, well, whatever. Let's just assume it's perfect. Good enough assumption. All right, that makes sense how Bloom filters work. What would we do if we felt like, and keep in mind this is mainly for large data sets, because obviously for a set of 3, we might as well just search rather than go through all the process of creating this filter. But if we had a really, really, really large data set, we were just trying to determine whether something was a member of that set, and we started getting too many false positives, especially for a type, especially for data where the a false positive would be extraordinarily bad, where you can't really have false positives. In that case, you probably wouldn't want to be using a Bloom filter unless it was just sort of bad. What strategies could you take to increase or decrease the likelihood of false positives? Well, can't we increase M and also increase K? What about just increasing K, increasing the hash values? What would that do for us? Does just increasing K necessarily reduce the number of false positives? It should. Right? Because, I mean, if we have a K of 5, now we need to have 5 matching 1s in order for our in order for something to be likely in the set instead of 3 matching 1s. Now, having said that, if our M is sufficiently small, then you might actually increase the number of false positives because, I mean, in this case, we have an M of 18. But if you have an M of 6, everything is going to be a 1 within that little bucket, right? So you're going to have a lot of false positives. So probably the best way to increase to decrease collisions is to increase M and marginally increase K. You certainly don't want K to approach M. You want K to be some sort of very small fraction of M, but still sufficient enough that you're recording enough data points about a specific word to determine that it's there. So if you had an M of 10,000 and a K of 2, you might have a lot of false positives if for a very, very large data set, just because of the nature, you're not recording a whole lot of data about individual strings. That makes sense? All right, so sort of homework assignment for today, but you will have one over the weekend. So I'm going to put up a something similar to what you did for Bloom filter. So it'll be another algorithm to explore. I want you to fully understand that algorithm for Thursday. There'll be a quiz related to the algorithm on Thursday. And then we'll start writing a solution to it, and you'll finish the solution over the weekend. Make sense? All right, so I'll put that up here probably in the next 15 minutes or so. All right, I will see everybody on Thursday.